Hey, welcome back. So we're moving on to our second data structure, another linked list. This time it's a doubly linked list instead of singly linked list. And basically, spoiler alert, all that we do is add a pointer to the previous node and the next node. So each node points in two directions. That seems like a very tiny change, and it is to the actual structure, but it has some large ramifications for the code that we write, the methods. But first, let's talk about our objectives. We're going to construct a doubly linked list. We'll compare and contrast doubly and singly linked lists, and we'll also implement basic operations like we did in the last section: push, pop, shift, unshift, insert, get, set, all those things. But first, let's start by just describing how it works. So as I've already mentioned, it's almost identical to a singly linked list. We have a bunch of nodes. There's no indexing, so it's still a linked list. It's not like an array. We don't have random access using numbers or an index. We have a head and we have a tail, but every node in the list points to the next node ahead of it, but also the previous node behind it. So that's where the doubly linked part comes from. Instead of just pointing to the next, it looks more like this. So we have a head pointing to the next item, and then it also has a previous pointer, but there's nothing because it's the beginning. So then our second item points to the next item, but also to the previous item. And all the way down to our tail, the last item, it has no next, but it has a previous. So as I already mentioned, it's a tiny change structurally to each node, just one pointer pointing to the previous node in each node, but it has a large impact on some of the code we write and the efficiency of certain operations. For example, when we're talking about popping off the last item of a linked list, a singly linked list like we have here, there's just one way, the arrows are pointing one direction. There we go. If we want to pop this last item off, and I go to remove from the tail, we have to iterate the entire list, and we have to find the second to last item. Remember, if you watched the video on pop in the last section, we had to find the second to last item and make that the new tail. We can't just go to the tail, like if we want to remove 16, we can't just go to 16 and remove it. We have to go to the item before it and make that the new tail. So we can't work backwards. When we're talking about a doubly linked list, however, if I want to remove the last item, I can just go to the tail and work backwards with .previous. I can move this direction. Instead of having to go from the beginning until the end, or the second to last item, I can just work backwards. Or another thing that is much, much easier, imagine that you wanted to print out a linked list in reverse, or you wanted to iterate it in reverse. If you had a singly linked list and you tried to go backwards, it is a huge pain. It's horribly inefficient. You basically start at the beginning, go all the way to the end, and you can't work backwards. So you could start over and go to the second to last thing, or you could make an array and just add things to that array one at a time as you go through, and then reverse that array. But there's no easy way to just start at the beginning and go, or start at the end and go at the beginning. With the doubly linked list, you can start here, and we can just do .previous. It's just as easy as going from the beginning, .next. And as we go through the section, I'll definitely spend time comparing the two singly and doubly linked lists and how they perform on certain operations. And you'll see that some of the code we write is a little bit more complicated because at the bare minimum, we have to now account for two pointers. We have to update a next and a previous every time we add something in or remove something or delete something. Well, remove and delete, that's the exact same thing. So we have some more work to do, but it's not that much harder. The real drawback is that it takes up more memory. So it's kind of always a trade-off in programming. More flexibility using a doubly linked list, but it also means more memory that's used up because now we're storing a previous and a next instead of just a next. Okay, so this will be something we come back to, but I'm going to leave this off for now at this. Singly linked list and a doubly linked list, they are very, very similar in a lot of ways. They're linked lists, there's no indices, there is an order to them, and they just consist of a bunch of nodes connected by pointers. A singly linked list is one directional, just .next, or, theoretically, just .previous. But a doubly linked list has both directions. It points to the next item and the item behind it, the previous item. In the next video, we'll implement our own doubly linked list, and we'll get working on push and pop and some of the other methods.